This is part 5 of solving linear equations. In previous parts 1, 2, 3, and 4, we discussed solving linear equations such as x plus 5 is equal to 10, or we also had 5x plus 1 is equal to 5. That one was from part 2. In part 3, we had questions like 3x plus 12x is equal to 16. In part 4, we had questions like 16 times x minus 1 is equal to 16. In part 5, we're going to discuss, let's say we have an equation with an x in the denominator. If you'll notice, in all the previous questions, x is in the numerator, x is in the numerator, x is in the numerator, and x is in the numerator. We did have some questions where we had fractions. We had in part 1, we had 1 over 10x is equal to 3 over 4, but the x was still in the numerator. Here in part 5, we're going to discuss, let's say we have x in the denominator. 4 over x is equal to 12. The easiest way to solve this question is by moving x to the numerator. How are we going to do that? If we multiply both sides of the equation by x, we'll bring x to the numerator on the other side. X, if we multiply this side by x and this side by x, what we're really doing is we're multiplying by x over 1. And since we're multiplying both sides by x, both sides of the equation by x over 1, that's okay. So over here, the x's are going to cancel out, and we're just going to be left with 4. 4 is equal to 12x. Now we're going to divide by the coefficient of x to get x alone. Divide by 12, and x is equal to 1 over 3. 1 over 3 is equal to x, or x is equal to 1 over 3. Now you will want to plug this in to make sure it is correct. In this case it is. Why does that work? When we had our original equation, 4 over x is equal to 12, what we just did was multiplied by x over 1. Since we did the left-hand side, we have to do the right-hand side also. Multiply by x over 1. And we were able to cancel out these two x's. Why were we able to do that? Because we're going to multiply the numerators and the denominators. 4 times x is 4x. 1 times x is x. 4x over x, these two x's can cancel out, and we're just left with 4. 4 is equal to 12, this is really 12 over 1. Or this is x over 1, so this becomes 12x over 1, or just 12x. Let's look at another example where we have the variable in the denominator. 4 over x plus 2 is equal to 16. Now this one's even more difficult than the one we just did. The one that we did before was 4 over x is equal to 12. This one over here has a binomial in the denominator. We can't just multiply by both sides by x. We can't go like this and like that, just multiply both sides by x, because we can cancel out part of a binomial and not the rest of it. So we're not going to do that. Instead of trying to bring just the x to the numerator, we're going to bring the whole binomial to the numerator. So we're going to multiply both sides of the equation by x plus 2 over 1. This is times x plus 2, or x plus 2 over 1. And let's see what we get. This x plus 2 over x plus 2, these two cancel out. So we're left with 4 is equal to 16 times x plus 2. Now we can distribute the 16 over the x and the 16 over the 2. And we're going to get the 4 from the left-hand side is equal to 16x plus 2 times 16 is 32. Now we can solve it like a regular equation. We're going to bring the constants to one side. 4 minus 32 is negative 28. 32 minus 32 cancel out. Negative 28 is equal to 16x. And we're going to divide away the coefficient of x to get x alone. And we get that x is equal to negative 28 over 16. And we can reduce that to negative 7 over 4. So x is equal to negative 7 over 4. So when you have a monomial, or just a plain x in the denominator like we had before, you could just multiply both sides of the equation by that monomial and bring it into the numerator. When you have a binomial, you can't just take away part of the binomial, so you're going to have to multiply by that whole binomial to bring the whole thing into the numerator. Let's try one more problem when we have variables in the denominator. In this question, we're going to have a variable in the denominator on both the left-hand side and the right-hand side of the equation. 6 over x plus 5 is equal to 10 over x plus 6. Now to answer this question, we need to get rid of the variable from the denominator and bring the variables from both denominators into the numerator. Doesn't matter which side you start with, let's start with the left side. We're going to multiply by x plus 5 or x plus 5 over 1 on the left side to cancel out the x plus 5 in the denominator. Since we're multiplying the left-hand side by x plus 5, we have to multiply the right-hand side also by x plus 5, or x plus 5 over 1. So this becomes 6 over 1, or just 6, is equal to 10 times x plus 5 over x plus 6. Don't forget about the x plus 6. Now we could distribute the 10 over the x plus 5. So 6 is equal to 10 times x is 10x. 10 times 5 is 50. 10x plus 50 over x plus 6. Now we want to move the x plus 6 to the numerator. We can't just move the x because it's a binomial. It's attached to the 6 with a plus sign. So we have to move the whole binomial to the numerator. So we're going to multiply by x plus 6, or x plus 6 over 1. Therefore, we'll be able to cancel out the x plus 6's on the right-hand side. And this left-hand side becomes 6 times x plus 6 is equal to 10x plus 50. Now we could distribute the 6 over the x and over the 6. This becomes 6x plus 6 times 6 is 36 is equal to 10x plus 50. Now this isn't such a hard equation. We want to bring the variables to one side and the coefficients of the variables with the variables, and we want to bring the constants to the other side, and then we'll divide away the coefficient of the x. Let's bring the variables to the right-hand side and the constants to the left-hand side. So minus 6x, 36, the 6x and the negative 6x cancel out, so we're left with 36 is equal to 10x minus 6x is 4x plus 50. Then we're going to subtract 50 from the right-hand side so that they'll cancel out, and we'll bring the 50 over to the left-hand side. 36 minus 50 is negative 14. Negative 14 is equal to 4x. Then we're going to divide away the coefficient of x to get x alone. Divide by 4 and divide by 4. X is equal to negative 14 over 4. Negative 14 over 4, 14 and 4 are both divisible by 2, so we could reduce that to negative 7 over 2. And of course, you would want to plug in this answer to make sure that you got it correct. In this case, it is the correct answer to the question.